This is part 2 of the video on logarithmic equations. So continuing on with our previous video, we want to do a few more examples so that we get lots of practice solving logarithmic equations. So here's one where we have a log plus a log equaling a number. So we're going to have to take these two logarithmic expressions and condense it into one log. So this will be log base 2, and since this is a plus, we're going to multiply 2x minus 5 times x minus 3, equaling 3. So when I have a log equal to a number, we can convert it to exponential form. We'll get 2 cubed equals 2x squared. Minus 6x minus 5x gives us minus 11x plus 15. So simplifying further and then subtracting that 8 is going to give us a quadratic 2x squared minus 11x plus 7 equals 0. So 2 times 7 is 14. The only things that multiply to 14 are 2 and 7. So again, here's one that does not factor, and we'll use our quadratic formula. So we have negative b plus or minus the square root of b squared minus 4ac all over 2 times a. That gives us 11 plus or minus the square root of 65 over 4, which is approximately 4.7656 and 0.7344. These would be the exact answers, and these would be the approximate answers. It does ask us to give exact values, but in order to check these, it's a little bit easier to check them when they're in decimal form. So when I check x equals 4.7656, and I plug it into 2x minus 5, I get a positive value. So 2x minus 5 ends up being 4.53 positive. And if I plug it into x minus 3, clearly a 4.7 subtracting 3 would also be positive. So this first one will work. The second one, x equals 0.7344, I can see that when I try to plug it into x minus 3, that's going to be less than 0, and so this answer does not work, even though it's a positive value. So to start with, the x value is positive, but when I plug it in here, I'm asked to take the log of a negative. So our only answer here is 11 plus root 65 over 4. Just the plus one is the solution. Here's an example with logarithms that are natural logs, and we want to give the exact value. So in this particular case, we have the natural log of e raised to the natural log of x. I'm going to bring this natural log of x down in front. So we have the natural log of x times the natural log of e minus the natural log of x minus 4 equals the natural log of 5. So the natural log of e we know to be 1. So we now have the natural log of x minus the natural log of x minus 4 equals the natural log of 5. So again, I have logs on both sides, but I need it to be a log, a single log equal to a log. So we're going to condense these. It's a subtraction, so we're going to divide. We'll have the natural log of x divided by x minus 4 equals the natural log of 5. So now we have the log of this number equaling the log of this number, so we take the logical step and say x divided by x minus 4 is equal to 5. I'm going to put that 5 over 1 and cross multiply. So I'm going to get this product equaling this product. So we'll have x equals 5x minus 20, or minus 4x equals minus 20, or x equals 5. So this is just a potential solution. When I plug it back in, you can see that the natural log of 5 would work, and 5 minus 4 would give us 1, and that would work. So this is a valid solution, and it does check. So let's take a look at one additional example here. We have log base 2 of 2x minus 5 plus log base 4 of x minus 3 equals 3. So this one has different bases, and so we cannot condense the left-hand side. So I need to change these either to base 2 or to base 4. And I'm going to do that using the change of base formula. I'm going to change the second one to base 2. So this is going to give me log base 2 of 2x minus 5 plus log base 2 of x minus 3 over log base 2 of 4, which is equal to 3. Now this is very convenient because log base 2 of 4 says what power do you have to raise 2 to get 4, and that is just 2. So we can multiply both sides of this equation by 2, and that will clear our fraction. So we're going to have 2 log base 2 of 2x minus 5 plus log base 2 of x minus 3. Notice this 2 cancels with this 2, equals 6. And now we have an equation that is just in log base 2. I would like to move this 2 up here so that I can condense these two. So that's going to give us log base 2 of 2x minus 5 squared times x minus 3 equals 6. Converting to exponential form, we get 2 to the 6th, which I believe is 64. So we have 64 equals 2x minus 5 squared times x minus 3. Now, we could multiply this all out and subtract the 64. We know we're going to get a cubic. What I would like to do at this point, because I don't really feel like doing that, is putting this one y1 in as 64 and y2 as 2x minus 5 squared and x minus 3 into my calculator. And then we'll do a second function intersect and find out when y2 is equal to y1. I would use zoom 0 so that it would fit on your screen. And when I do the intersection, I get 5.198. I still do need to check this, but let's take a quick look. If I check this, it's 5, say we'll call it 5. This would give us about 10 minus 5, which is positive, and 10 minus 3, which is also positive. So this does in fact check. So in summation, when we're talking about solving a logarithmic equation or an exponential equation, we want to change the given equation into one of the following forms, where a and b are real numbers a has to be positive and greater than 1. If we have a to some function equal b, we're going to convert to log form. If we have a log equal to b, we're going to convert to exponential form. If you have a log base a of something equal to the log base b of something, we can set these arguments equal to one another. So it's equivalent to the equation f of x equals g of x. If we have a more complicated equation like e to the 2x plus 1 times e to the negative 4x equals 3e, we are going to want to combine these using the rules of exponents, and we're going to have to manipulate things so that we get one of the 3 forms above. And always check that the proposed solution is in that domain of either the exponential or the logarithmic function. So I like to make myself a little flow chart, and the flow chart looks like this. You either have an exponential equation or you have a logarithmic equation. If you have an exponential equation, it's either going to be the form a to the x equals a to the y, or a to the x equals y in general. If you have the first case, you just equate the exponents. So if the bases are the same, you just say x equals y. If you have an exponential equal to a number, then you're going to convert it to a log form, and you're going to have log base a of y equals x. When you have a logarithmic equation, it's one of 2 types. You can either write it as a log base a of y equals x. Similar to this over here, we would then take this and convert it and make it a to the x equals y. The other thing that you may get is something like log of a equaling log of b, in which case you just equate the arguments and say a is equal to b. Those are the only 4 kinds, and of course we saw, like for the logarithm, if you can write it as a log equal to a log, then you can apply this, but that may involve you condensing one or both sides of the equation. I'm going to make one additional video with applications and models of logarithmic and exponential equations, so look for part 3 in your list.